Hello, sixth graders. Mrs. Dubé here, coming to you with lesson 10.7 on page 571. And today we're going to be talking about composite figures. Don't let the big words scare you. Composite figures. The essential question, how can you find the area of a composite figure? Okay, easy enough because we've already found the area of triangles, parallelograms, squares, rectangles, trapezoids. And so composite figures are just made up of two or more simpler figures, such as a triangle, a quadrilateral. Remember, quad means four, so quadrilaterals are any four-sided figures. So composite figures are just a mishmash of quadrilaterals, triangles, trapezoids, etc. So let's get to unlock the problem. The new entryway to the Fun House at Happy World Amusement Park is made from the shapes shown in the diagram. It will be painted bright green. Juanita needs to know the area of the entryway to determine how much paint to buy. What is the area of the entryway? So if we take a look, it's a new entryway. It's made from the shapes shown in the diagram. That's going to be important. It'll be painted bright green. I don't need to know that. She needs to know the area of the entryway because she needs to know how much paint to buy. So we need to find the area of the entryway. A lot of the words in that problem are superfluous, meaning we don't need them. They're not going to help us solve the problem. So if you look over here, we have two congruent rectangles. By congruent, I mean same shape, same size. I could take this rectangle and move it right over onto this rectangle. Oh, they're going to be the same one. I was going to try to move it. And you wouldn't even know that one was on top of the other one. Okay, so congruent, same shape, same size. This triangle is also congruent to this triangle. And then we have a lone square right in the middle. Okay, so you should be thinking right now, well, I guess I would only have to find the area of one of the rectangles and times it by 2, or add it to itself. And I only need to find one triangle and times it by 2 to get the area of the two triangles. And then the square, we just have to deal with 1. Remember, all of these little blue boxes mean 90-degree angles. Okay, that means these lines are perpendicular to each other. If you look over here, sometimes you just have to study these figures for a minute. So this rectangle is 4 feet by 10 feet. So if this is 4 feet and this is the same length as this would also be 10 feet. If this is 4 feet, then this must be 4 feet. This is already labeled 4 feet. This must also be 4 feet. And if this is a square, then, and this is telling you right here that the height from here to here is 4 feet, then that means the side is 4. That's how we definitely know it's a square because it's 4 by 4 by 4 by 4. Okay, so that's what this little 4 over here is showing you. It's just showing you that height. So you can feel free to fill in any of those dimensions you need to before you get started. All right, so on your loose leaf paper, and if you need to get one out, you just need to please pause the video and take out a piece of loose leaf paper. Okay, what I typically do, and I'm just going to be writing into this a little bit, but I have 3 shapes that I need to find. I need to find the rectangle area. I need to find the triangle area. And I need to find the square area. So on my loose leaf, I might do a triple T chart to find these answers. It will help me organize my work, right? Okay, and it will help me keep everything straight and know what I have to add or times by 2. So area of a rectangle we know is length times width. Okay, and if you were to do your little box of goodness, which I don't know if you really need to do for this one, but let's keep it consistent. We need the area. We'll say the length is 4, the width is 10, however you want to do it. So the area of this rectangle is 4 times 10, so that's 40. But remember, we have 2 of them, right? So the area of both rectangles together are 80. So I'm just going to put 40 and 40. All right, great. Now, triangle. I'm just going to move this line over to give myself some more room. Okay, the triangle, you have to remember, is half the length times the width, or the base times the height. So the area of the triangle, we know the height is 4, because it tells us that right here, and we know the base is 4, right? So 1/2 4 times 4, well, we know 4 times 4 is 16, so A will equal 8. So the area of each of these triangles is 8. And of course, you'd have your box of goodness. These are kind of really easy numbers, so that's why I'm kind of going through a little bit quickly. The base was 4, the height was 4, and then you just fill in. Okay, and then we have our square, and we know area of a square is length times width, or when it's a square, we use side squared. Okay, our box of goodness, area, we're looking for it. Side, so we know already that the side of this square is 4. This is 4, 4, and 4. So the side is 4, and we're just going to square it. So 4 squared, so the area of this is 16. Okay, so then all you have to do is you can do 40 times 2, which I did here. 8 times 2 is 16, so we have 80 for the rectangles, 16 for the triangles, and 16 for the square. And then you just add them all up, and you get 112 feet squared. Okay, so I'm not going to go through all of these step 1, 2, 3, 4, 5. Step 1 is just saying find the area of the rectangle. Step 2, find the area of the triangle. Step 3, find the area of the square. Step 4, find the total by adding them together. We don't really need to do all that if we have our triple T chart on our loose leaf. This keeps our information organized, neat, and it keeps us on the right track for solving the problem. All right, please turn to the next page, example 1. On page 572. Find the area of the composite figure shown. Remember, composite, base word compose, so it's composed of different shapes. First, you have to kind of study it to see what we know. So we know this is a triangle, okay? It's 20 on its diagonal here. 16 is the base, and the height is 12. I'm just going to label that 12 here. I don't know if I need that 20 for anything. Do you think we do? Not sure if we need the 20 for anything. So we know area of a triangle is 1/2 base height. Well, this is our base and this is our height. So I'm not sure why they put this 20 there. Maybe we'll need it, maybe we won't. Okay, now if this figure here is a 12 by 12, then this must be 12, and we already know this is 12. So this is definitely a square, and we know that's just length times width, or side squared, or base times height. Okay, and then when we look at this figure, we have one set of parallel sides, folks. This side and this side will cross at some point, but the parallel sides will never cross. And remember, the sides that are parallel to each other are our bases, base 1 and base 2, and we know the dotted perpendicular line is our height. Okay, so when you see a composite figure like this, really study it, see what you know, see what you don't know, figure out what you don't know, and then begin your triple T chart. It would just be a double T chart if there were only 2 shapes, right? So I'm going to do this again with our triple T chart. Okay, and we put our shapes up top. So triangle, trapezoid, and square. Square's easy. Area of a square is side squared, or length times width, or base times height. Triangle, 1/2 base height. The reason is because it's half of a quadrilateral. So if a quadrilateral, the area is base times height, or a parallelogram, however you want to say it, 4 sides, then a triangle is half of that. And then the trapezoid is just the triangle formula, but first you have to add the, say it out loud, bases together, right? And then multiply by your height. Okay, so we're going to kind of just ignore all of this, and we're just going to use our triple T chart to help us get through this. So area of a triangle. Remember, you're going to copy it each time, and you should have loose leaf paper out. The base is 16, and the height is 12. Okay, so I'm going to take half of 16, which is 8, and then times it by 12. So my area of the triangle is 96 centimeters squared. Okay, so that area of the triangle, 96. Okay, now let's go to area of the trapezoid. Area equals 1/2. Our bases are 9, and this 12 is the same as this base, right? So our bases are 9 and 12, so we're going to add those together. And then we're going to times it by our height, which is 6. Okay, so the first thing I'm going to do is add together my bases, and I get 21. Now remember, the commutative property tells us when we multiply, we can multiply any way we wish. I'm not going to take half of an odd number. Instead, I'm going to take half of 6 and get 3. Then I'm going to times that by the odd number, by 21. Okay, so 3 times 21 is 63. So the area of my trapezoid is 63. All right, let's move over to the square. Should be pretty easy. It's 12 by 12. So area equals 12 squared. So the area of this square is 144. Okay, we're not done yet. Think to yourself, what do we have to do? Okay, we have our 3 shapes. And we have our 3 areas. So hopefully you know the next step would be to add them together. 144 plus 63 plus 96. So 4 and 6 is 10, and 3 is 13. Carry the 1. 9 and 1 is 10. 4 and 6 is 10, so that's 20. Carry the 2, 3. So our answer is 303 centimeters squared because area is always squared. Okay, down to the next one. I know I'm going to run out of time, but oh, I really, 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 really love these. These are great. So find the area of the shaded region. I don't know if you can see it on here, but this is the shaded region. Around the smaller square is the shaded region. Okay, so find the area of the rectangle and the square. So the first thing you're going to do is find the area of the rectangle. Pretend the little square isn't even in there. So if we're just going to do length times width, and we're just finding the area of the rectangle, okay, so we're just going to do length times width. And don't be like befuddled by this, but notice this unit is feet, this unit is inches. So right away, let's just change this to 12 inches so that we have our same units. So back over here, we're going to say the length is 12 inches and the width is 6 inches. So we have an area of 72 inches squared. Now that's for this entire rectangle. So think to yourself for a second. That's the entire rectangle, but we only want this much. So what do we have to do with this area of this square? I'm thinking, and we know it's a square, by the way, because that says it's 3 inches and this says it's 3 inches. So that area of the square is 9 inches. So wouldn't I find that area and then subtract it out from the rectangle? Okay, so side squared would be 3 squared, which would be 9. Okay, and then you have to subtract out the area. So you have 72 inches squared minus 9 inches squared will give you 63. So then the shaded region would just be 63 inches squared. Excellent. Okay, under the share and show, I'd like you to do number 1 on your own for tomorrow, and on your own, number 4. Okay, everybody, have a great afternoon or evening, and we'll see you in the morning.